Thanks for inviting me, CASPA, and thank you all for attending this talk. So how to boost your career with AI? I think these days we hear a lot about how artificial intelligence is going to take away all of our jobs. So I thought it'd be good to have a talk where we talk about how it can enhance your career. So what do I mean by boost your career? Right now, we've gotten to a point with artificial intelligence that is very accessible to the everyday person. You don't have to be an artificial intelligence PhD to be able to take advantage of artificial intelligence. And in your own careers, with your own domain expertise, if you combine your own domain expertise with the technologies of AI, namely machine learning and deep learning, you can create greater value. And it's this greater value applied in your role and applied in your organization that will allow you to increase your career prospects. So in this talk, I want to go over, for those who don't know, what are the basics of AI? What is AI capable of today? How can you start an AI project within your own company? And then discuss some caveats that you need to understand as you go into an AI project, if you choose to do so. So about me, he introduced me very well, so I'm going to skip this slide. Wow. So what is AI and machine learning? Artificial intelligence is the science of creating machines that have an intelligence equal to human intelligence or surpassing of human intelligence. So it's a large field, it's a very broad field. It includes areas such as robotics, some parts of computer vision, and of course machine learning. So for the rest of this talk, I'm going to focus on just these two portions of this diagram, the machine learning and the deep learning. So machine learning is one pillar of artificial intelligence, and the focus there is on building algorithms that can help machines to learn from data. And there are many different algorithms. One set of algorithms are what's characterized as deep learning methods. So deep learning methods are typically based upon neural networks. And they've proven to be very powerful. And in many areas, just in the short few years, the results from a lot of deep learning algorithms have surpassed a lot of the work of the last 30 years. What AI is not. So just want to point out that some things may seem like they're intelligent, but when you look under the hood, they're based on a series of rules. Sometimes hundreds or thousands of different rules to try to address all the situations. But if those types of algorithms encounter a brand new situation, it's going to be hard for them to respond. So intelligent systems should be able to have some flexibility and respond to brand new situations. How is machine learning, how is this industry a little different than what's gone on before? I want to point out that there are three things that make this advantageous for all of us. One is there's open sharing of algorithms and techniques. So let's think about another type of technology. So let's say Apple. You don't see the head of manufacturing of Apple giving seminars and giving classes on how they manufacture their products. You don't see the head of their material science giving you details on how they fabricate some of their best materials. But with machine learning and with artificial intelligence, you see the leaders of this field giving classes, giving lectures, and sharing not only what they're doing, but giving you a really in-depth look at how they're doing it, what algorithms they're using, what code they're using. So I think this opens up a lot of opportunity for us to learn. Non-proprietary software platforms. So I have a PhD in mechanical engineering. Back when I was in graduate school, all the software I use, all the hardware I use costs hundreds of thousands of dollars. So I do production systems on AI. Today, all my software is free, basically. I have to develop some of it, but a lot of the foundations of my software is basically open source. And I can look under the hood, and I can modify it as necessary, as I need. And the hardware is pretty cheap as well. So I use a MacBook for some of my preliminary models, but I can, at any time, I can spin up a machine with GPUs or CPUs for a really low price comparatively, compared to what I was dealing with back in grad school. So that leads to the third thing. It's very inexpensive to get world-class results because of the free software, open source and free software, and because of the cheapness and availability of machines. It's inexpensive. So I quickly want to go through some of the overview of methodology. So in machine learning, what we do is we build models, and those models have an output. Two basic types of output. One is a prediction. A prediction could be a qualitative or a quantitative answer to a question. So take the example of a temperature model. I could feed in an algorithm information about the location on Earth, the latitude and longitude, the time of day, and other factors. And I could ask it, given this time of day, given that I'm in Milpitas, what should the temperature be? And it'll give me a prediction. There'll also be, it could be a qualitative prediction, so it can give me, it's hot or it's cold. So those are predictions, but then you have a set of algorithms that give you interpretations. And in many organizations, these are more important than the predictions. So right now, I'm working with a nonprofit, and they have a lot of data about their members. And what they want is not so much predictions about what their members will do, but they want to know what factors drive their members' engagement. So I build models, and these models give me predictions, but what they really want to know is that members who have a high education are going to be less likely or more likely to engage. So, let's see. Also, human guidance. So when you build models, sometimes you give it guidance, sometimes you give them, when you train a model, you give it the answers, and then help it to build an understanding of a situation. And sometimes you have non-supervised methods where you don't give it any labels or any answers, and you let the machine find connections between your data on its own. So I want to quickly talk about a personal example. So one night, I was woken up early in the morning, and someone was bumping into furniture downstairs. And so I went downstairs to protect my family. And what I discovered is it wasn't a person down there, it was my Roomba. It had been misprogrammed to turn on at 3 in the morning instead of 3 in the afternoon. So I thought, what if there was a way that I could determine without having to get up and check whether or not there was a real intruder in my house. So what I did was I took a vibration sensor, an accelerometer, placed it someplace on my floor, and used it to read the vibration caused by footsteps. So this is vibration readings from me walking across the floor. These peaks you see are footsteps. I transformed this into a 2D image, and I trained a model called a support vector machine to do classification on different types of images. So I did images for myself, images for my wife, my son, the Roomba, of course, and anything that didn't fit within these categories was deemed an intruder. And so using machine learning, I'm able to do something very powerful here, just from this data, being able to figure out who's in my house. So I want to talk about some other general areas of application, just to give you an idea of what artificial intelligence is capable of. A lot of times when people talk about artificial intelligence or machine learning and deep learning, they go by algorithm. But since this is a kind of a practical talk, it's focused on actual practice, I want to talk about the types of data that people use and give you a non-exhaustive kind of survey of what is capable these days. So every example I'm going to show you, if you know a little bit of Python, functions, classes, basic data manipulation, you can implement all of this stuff. So first I want to talk about images and video. So I divided this slide into classifiers and generators. So classifiers are able to take images and classify them into one class or one group or another. And so we see this guy, his name is Dat Tran. He's a machine learning enthusiast. He's been able to train the algorithm to recognize, using the video, the objects in the screen. So you can see that it recognizes the chair, recognizes the cup, the banana, the phone. It even puts a box around him. So it both classifies these images and it puts a bounding box around the images. So we can take this same principle and apply it to this application. So this is a semiconductor that's been manufactured, and the people that produced this work were able to train an algorithm to recognize defects. So just like here, where you recognize an object and you place a bounding box around it, this algorithm is programmed to recognize defects and place bounding boxes around the defects. Here's a very similar example using the same principle, being able to classify different pixels of this medical image into harmful cells, which are then colored green, and benign cells, which are purple colored. Again, some of the same principle used here in recognizing a face, recognizing that this is a face in this image, and then being able to recognize whose face it is. So for most of these, I'd say for these techniques, a convolutional neural network is used. For this one, a convolutional neural network is used to recognize that this is a face, and something called a Siamese network is used to identify whose face it is. Next, we have generators. So generators are algorithms that produce generated images, brand new images. Here's an example that was produced I think 2 or 3 weeks ago by a student of deep learning. This student fed an algorithm called a GAN, a generative adversarial network, pictures of stained glass windows. And it produced a model that could take an input picture, such as this landscape picture, and produce a stained glass version of it. So this took maybe a few hours to put together and produce. And some of the possibilities here I think are pretty wide. So this is called style transfer. Another use of a GAN is image enhancement. So if you look down here, you see that this is a very pixelated, low resolution image. The GAN, the generative adversarial network, was able to create a much sharper image here. And what's exciting about this is that the GAN is making decisions about what to fill in and how to fill in things. It could take this background and make it sharp, but it's had a lot of pictures of animals that have backgrounds that are not focused. So it made a decision to make this background not focused. The pattern on this bird's wing is not such a trivial thing to fill in these blanks to make this pattern. It does that is because it's seen different pictures of this type of this species of bird, and is able to understand that it should fill in the blanks or it should fill in the resolution using a particular pattern.
So can you apply these on the video generators?
Yeah, you can.
Video.
Say again?
Also, you can apply the video applications.
Well, a video is just a set of frames.
Yeah, frame by frame, like
Yeah. So I want to quickly kind of go through this, make sure I'm having a good time here. So for natural language, text and speech, spoken language, we have also classifiers and generators. These aren't the only two, but I'm just doing this to highlight some of the possibilities now. So one type of classification that's done is something called sentiment analysis. I can train a model to recognize different text or different spoken words and figure out the emotional content of it. Is this a happy or a sad comment? Is it a negative or is it a positive comment? So applying this to story reviews, we're able to see that the algorithm can recognize whether or not this comment is a bad one, characterized by red, or is a good one, characterized by green. Another application is taking whole articles, whole documents. So in this example, this algorithm took around 800,000 documents 800,000 news stories, and is able, without labels or without human help, to cluster them or classify them into different types of articles. So we see there articles about disasters are purple, articles about energy markets are kind of gold or brown here, and there are other clusters. So that's the classification part of natural language. There are also generators. So I think most of us are familiar with Siri or with Alexa, where we can talk to Siri, and Siri will give us a natural language answer. Siri, what time is it? Oh, it's 10 o'clock. So that requires both natural language understanding and natural language generation. Being able to give Siri the information it needs from a data point of view and have her convert it into a human understandable speech. With text, we have some examples here of image captioning, which is because of deep learning has taken some advances in the last 2 or 3 years. So taking this image as the input, the algorithm was able to create this caption, a person riding a motorcycle on a dirt road. That's pretty good. It's not always perfect, so here's one, 2 dogs playing in the grass, and there's actually 3 dogs here, right? So, but the fact that it's able to take an image and understand what is in the image and give a sequence of words to describe the image is a pretty advanced thing now. Here's a more practical example. There's a company that takes spreadsheets and produces monthly reports from those spreadsheets. So the algorithm that this company is using is able to make decisions about what to put in the report, what's important, and what's important enough to make a figure out of. So it's creating the text and the figures and the headings for the report. So tabular data, kind of going on to the last example. Tabular data, like from Excel or from relational databases, we can take and apply traditional machine learning techniques and also deep learning techniques too. So here's an example of something I did. This is the city of Oakland. So this is predictions about if I park my cheap car in Oakland, how big of a ticket will I get in what area? So, because I like to not pay parking meters. So the areas in red are the areas where I'm going to get the highest parking ticket. So maybe I'll park in a cheaper place and take an Uber to where I want to go. But this was generated from tabular data such as this, with columns for latitude, longitude, time of day, the amount of tickets that has been gotten. So I was able to train a model using historical data in the last 4 years of all the parking tickets that have been generated in Oakland to do this. So you can also do regression. This is a type of regression where you're taking data, you're relating hourly electricity to outdoor temperature. You can take tabular data and do clustering, where you don't label the data and have the algorithm make relationships between the data and create clusters and segments. And you can label the data and have the algorithm create clusters and groups. So this is clustering, this is classification, and the algorithm was able to create segments of low-risk bank customers and high-risk bank customers. And lastly, I'll talk about time series data. So a lot of us have to deal with sales forecasts, with inventory forecasts. There have been in the past, this is a lot of statistical algorithms, statistical methods to deal with forecasting data. But I'd say deep learning is able to produce a lot of very good results depending on how frequent and how deep your historical data is. So it's an alternative to use for forecasting. And there's some companies that are addressing this need. So this is output from a company that works with retail shops. And it takes their historical sales data and produces forecasts and predictive reports for them. So it's already possible to just give your data to some vendors and have them use their internal machine learning algorithms to produce forecasts. So I did all that to give you an understanding of what AI is and what are the capabilities of artificial intelligence. And so going back to the first part of my talk, the object is to have your understanding so that you can understand what value, or what's possible in bringing value to your own work and to your own domain expertise. So I want to talk about what drives an AI project success. Because when you bring value to your organization, when you bring value in your role, you're probably going to do it by creating a project around machine learning and deep learning. So what drives the success? I say out of this list, the two that stand out to me are collecting data. There's a lot of data sets that are available, but if you have a specific situation, you work in a specific industry, maybe the data that you need is not published. So you either have to find someone with the data, or you have to start a program in itself to produce the data that you need. The other one that stands out is integration with your actual operations and decision making. I've seen cases where sometimes people make a very nice algorithm, very nice output, very nice visualizations, but no one uses it because it's not relevant to the daily or monthly operations of their organization. So you want to make sure when you start your own project, even if it's at a small level, that you tell people about it and you get them on board, and you get them and you have them commenting on what you're trying to produce, so that you don't spend a lot of effort and have a nice model that no one uses. These figures at the bottom I want to point out, these are from a startup, a machine learning startup in Israel. And these figures are poignant because it talks about the expectations of effort in a machine learning project versus what is reality. Most people think, and I myself was in this group before I started getting into this, that most of a machine learning project is taking one of those algorithms I explained before and applying it to some data and just refining the algorithm until you get it close to perfect. But in reality, that part is a very small sliver of what you actually do. Part of it is what I said before. You have to collect the data. You spend a lot of effort in doing that. You spend a lot of effort in building your infrastructure, building your ETL, building your data pipeline. And then there's the effort spent in integrating your model with your organization. So given that you're going to do a project, what are some ways to access AI technologies? So if you have some understanding of how to code, you can use a lot of existing libraries and packages to produce some of the results that we saw earlier. So I use Python mostly, but if you have an understanding of MATLAB, R, C++, and Scala, there are packages and there are libraries that you can use to get up to speed and to develop your own algorithms. So there are cloud platforms that can accept light to no coding that exist. So I use AWS a lot to host my code, but AWS, Google, and Watson, to a large extent, have some apps that allow you to input data, and it applies the machine learning algorithm for you. I think the best one is IBM Watson. If you go there, there are a lot of places where you can, and a lot of applications where you can input data, just upload some Excel CSV files, and it'll produce forecasts, it'll produce classifiers, it'll produce regression models. And then hire is the last one. So you can hire direct employees that are data scientists or machine learning engineers. You can hire consulting firms like my own to help you. And you can hire, there are a lot of freelancers that understand machine learning. So 3 career roles if you're going to do a data science project or a machine learning project. One is if you're an individual contributor, if you're a data scientist, or if you're a decision maker. So I'm not going to talk about data science. If you're interested, I have some slides in the back about that. But I want to focus on ordinary people who just have a domain of expertise who want to implement machine learning. So if you're an individual contributor, your goal is going to be to enhance your performance by using your domain expertise. The first thing you need to do is to understand what are the most relevant questions that you have in your organization, and what data and domain expertise can you apply to those problems. A lot of times people don't ask the right questions up front, and as I said before, you can produce a model that's pretty and looks nice, but it's not used because it's not relevant. So understand what's relevant in your role and what data you have to apply to it. If you don't have data readily available, you may have to go and collect it. Or you may have to go ask different people in your organization for it. So once you have the data, you can start off small and simple. Take a small part of the data. So for example, if you're a salesperson, if your organization sells several products in several regions, start off with one project in one particular region and use some very simple algorithms to predict what are going to be the sales in the next 2 or 3 weeks or 2 or 3 months, and see what happens. Depending on if you get good results or bad results, you're going to go through a feedback loop of refining your information, refining your model. Once you get your model, so there are two paths here. One is for someone who's a coder, and one path for someone who's not a coder, and I kind of went over those before. Once you refine your model, then you have the task of integrating it within the rest of your organization. So if you're a decision maker, you have to look at this from the point of view of an entire organization. In the very beginning, in addition to understanding what the questions are that are relevant, you have to understand what resources you have to apply to it. What talents people in your organization have. If you have people in your organizations that understand how to program, maybe they can get up to speed very quickly on doing machine learning. If not, you may have to hire outside, or you may have to use one of those AI as a service products. One of the best ways in an organizational level is to do a proof of concept. So it's very similar to the small project I mentioned earlier, but this type of project has a buy-in of a lot of the functional areas within your organization or your department. And then once you develop a good model and the project is successful, you have to think about, and putting this in production, where does your data sit? Are you going to have this data on a database? Are you going to have it in the cloud? What's the size of the input and output data? What's the I/O size? What's the bandwidth? What's the frequency of output that you need from your model? Do you need predictions once per second? Do you need a batch of predictions every month? And then how are the model outputs accessed? Sometimes I produce models for organizations, and they take my models and they produce dashboards based on the models. So that the people in the layman in the organization, they don't really touch the algorithm of the code. They can just check off a few boxes and produce the output that they want. So the customers in your organization who are going to consume this data should be a large consideration. So other considerations, data privacy, data security, and ethics. So security and privacy. In dealing with personal information, I think we've seen a lot of stories recently, particularly with Facebook, where people are suing Facebook because they feel that their data has been misused. So whenever you are dealing with personal information, like names, emails, phone numbers, you want to make sure that you take some efforts within your project to scrub that information. So there's something called a hash that you can use to replace a name with an alphanumeric series of characters that represents a name or an email address. You want to make sure you have agreements in place with all of the customers that provide you data. And those agreements are going to outline how you will use the data. You want to understand the regulatory climate of your particular industry. So, for example, healthcare has very stringent regulations around personal information called HIPAA. But your particular industry may have their own regulations. So then there's general data protection and security. So when I deal with my clients' data and then their own organizations, we use things like VPNs, firewalls, we use password managers, malware, software to make sure that there's not going to be any harm to our data, harm to our data sets, and also there won't be any leakage of critical information. So lastly, I wanted to talk about ethics in AI. So there's been a lot of stories in the news about different ways that organizations have misused data or using machine learning algorithms and having some unintended consequences. So here are some examples that I put on this slide, but some questions you want to consider is there bias in your data that you're not considering? And it's good to have a committee of people take a look at the data that you have and just to do some checks against different groups of gender, different ethnic groups, and so on. Is there bias in the subjective targets? What I mean by that, here's an example of a generator that generates a picture that is supposed to be more attractive. And so for this person, more attractive to the algorithm is a narrower nose and a lighter skin. So this person wasn't very happy with that assessment. So you have to look at, when you have subjective targets, you have to consider whether or not it'll maybe offend some of your audience or some of your customer base. When you look at results, what are the error rates? When you control for different ethnic groups, when you control for gender, are the predictions of your model, do they have greater error for women versus men? If they do, then you need to take a close look at your data and how it's put together. And then if you have mistakes that inevitably happen, do you have a process to deal with mistakes, especially ones that happen in public? So I'm at the end, and in summary, AI and deep learning is becoming very accessible for the layman. It's becoming very accessible to people to utilize, whether or not you have coding expertise or statistical expertise. Using your domain expertise, using your own data, is the key to get some groundbreaking results with using artificial intelligence and machine learning. And a good model is an essential but a small part of a successful AI project. So thank you. Thanks very much.
Yeah, we have some questions to Dr.
Yes?
One slide showing the term called KPI. What does it mean?
Key performance indicator. So what are the key metrics in an organization? So for one department, it could be, what are the sales month over month? So it's just a key performance indicator. Yes?
Yeah, before the artificial intelligence, there's a term called business intelligence. And
Yes.
What's the difference between the two? In your point of view?
So the question is, what is the difference between artificial intelligence and business intelligence?
Yeah, it's an older term.
Yeah, it's an older term. I think to a certain extent it's kind of a fad term. Business intelligence to me just means business analytics on a large amount of data. Whereas artificial intelligence could be a broad, like I said before, it's a broad range of items. It could be robotics, it could be machine learning. It could refer to algorithms. It could refer to a bunch of things. So to a certain extent, a lot of these terms are buzzwords, and they overlap. They do overlap. Yeah, but I would characterize business intelligence as analytics on business data. And artificial intelligence is referring to a set of algorithms and techniques for making machines as intelligent as humans. So they have different aims, slightly. Yes?
Once you generate a model, how do you know how good the model is?
So there are different metrics depending on the algorithm that you use. One well-known metric is just to use loss or error in the predictions. So if you have a supervised model or one that has training data, you have a set of data that's set aside that has the actual ground truth or the actual answers, I'll call it, and you give the machine a test on this data, and if it passes the test, past a certain threshold, like maybe 85%, then maybe this is a good model. If it doesn't, then you do some things to refine it. And there are other performance metrics, but a lot of it is online and well known, probably known. Yes?
If someone, especially in this group, want to enter this field, either ML, AI, or whatever, analytics, what is the best way to demonstrate to your prospective employer that you're proficient or you have the skill?
Okay, so this is a slide I said I put in the back. So this is a data scientist. So you have some areas of knowledge in math, in coding, and in data science. So if you have a good understanding of these things, that's one level. Once you get your foot in the door, you get an interview, they're probably going to ask you questions or give you some coding challenges based on this information. To get your foot in the door, you should have a GitHub repository. You should maybe have a blog where you post results or where you talk about technical issues. And then people see that and they say, okay, this is a person who's serious about this and he has actual results. And you can use those results as a conversation starter when you actually have an interview. And then network. Go talk to people. Become known. Yeah.
Then do you suggest to use AWS as a platform to do this?
AWS can dig in your pocket. It can cost you some money if you use it for this. I think there are other platforms that have a free tier. AWS also has a free tier, but there are other platforms that have a free tier as well. So you just have to look at the cost of it. Not most, but a lot of organizations use AWS. It's becoming more ubiquitous, but it's not the only platform to launch models on.
Thank you.
No problem. Yes?
Yeah, how relevant are Kaggle challenges in data science? I mean, if let us say I have a few Kaggle challenges that I've solved and I have the code on GitHub repositories, how relevant does the industry take them to real world problems?
Wait, say that one more. Can you repeat the question? Sorry.
Yeah. You have a lot of challenges being posted on Kaggle, which is an open source code development community. How relevant are those challenges to what the industry does right now in AI?
So let me make sure I understand your question. So you said there's a lot of challenges on Kaggle.
Yeah.
And so how can you apply these challenges to real world problems? Some of them you can, some of them you can't. I mean, some of those challenges are posted by actual companies, and those are their actual problems. So you see that a lot. But sometimes you can't. And one way I went, which is why I founded this company with my partner, is because I found that the best practice is doing real world things. So I would go out and find customers and say, hey, I have this expertise. You have this problem, let me work on it. So maybe going out and doing freelance work or finding people in your network that have departments that have problems. So just tackling real world problems is sometimes the best way to get the real world experience. Yes?
I have a question. You mentioned that you are in a consulting company, so have you ever encountered a case where you're dealing with a client's data and you're deciding whether to minimize type 1 or type 2 error, and how do you justify it to your clients?
So the question is, if I ever had a client where I wanted to or they wanted to?
Whichever.
Okay.
Because he's asking, well, going off of his question, how do you measure your model performance? And one of them is, you said, is error.
Right. So like, how do you? If there's a question of reducing type 1 or type 2 error, or metrics like precision and recall, how do you go about doing that when you're dealing with a customer? It depends very highly on the customer's problem. Like, when you're dealing with, when you're learning about precision and recall, the big example is, are you dealing with people who are dying? Are you dealing with people who just might be a little upset because their magazine didn't arrive on time? Right, so it depends on the consequences on if you have a false positive or false negative, or so.
Last question.
Yes.
Yeah, in your one of your example, you transfer audio data to image data, then do machine learning.
Yes.
Can you derive, suppose nature's idea to take audio data directly to training? Why transfer to image?
Because I felt that there was more information in the 2D image than in the 1D data.
The entropy is always the same, no change.
So not really. So if we go back to this. You're talking about this, right?
Yeah.
Wavelet transform. So from my point of view, right? I mean, of course, theoretically, there's only one set of information, right? There's no information is created, right? But from a machine learning point of view, and cleaning and preparing my data, if I feed this into it, I'm feeding one-dimensional data, like one column of data, right? Timestamp and magnitude of the footstep or the vibration, right? Here, I'm transferring frequency and magnitude data to the algorithm. So this is there's not more information, but there is more data, if that makes sense. So that's my reasoning behind doing that. And we can talk more about it. Yeah.
Okay, thank you.
Thank you.
Okay, so this concludes our career talk. Thanks again to Dr. Pita. Thank you.